In 2015, a wave of exhilaration swept through the global space community. For decades, Pluto remained a distant, fuzzy dot on the edge of our solar system, a mysterious world we knew very little about. Up until that moment, the best image we had of the Pluto system came from the Hubble Space Telescope. But even Hubble, with all its advanced optics, could only show us a blurry, pixelated version of this icy dwarf planet. Tiny, dim, and barely distinguishable, with some color variation at best. That all changed dramatically when NASA's New Horizons spacecraft finally reached Pluto after an incredible 9-year journey across nearly 5 billion kilometers of space. This was no ordinary mission. It was a historical moment. For the first time, humanity could gaze upon Pluto and its moons in breathtaking detail. It was as if we had finally pulled back the curtain on a long-lost part of our cosmic backyard. What exactly did the New Horizons probe discover? Before we dive into those jaw-dropping revelations, let's talk about why this mission was so important. Pluto was once classified as the 9th planet in our solar system. However, in 2006, it was demoted to dwarf planet status, sparking fierce debates in both scientific circles and public forums. Despite this downgrade, Pluto remained an object of intense fascination. It symbolized the mysterious frontier of our solar neighborhood, the gateway to the Kuiper Belt. This brings us to the Kuiper Belt itself, a vast icy region of the solar system beyond Neptune, teeming with dwarf planets, comets, and remnants from the solar system's formation. Pluto is one of the largest known objects in this region, making it the perfect target to better understand this mysterious belt. But due to its extreme distance from Earth, getting there was a formidable challenge. So how did New Horizons manage it? To reach Pluto before the 2015 flyby deadline, NASA had to act fast. Engineers and scientists launched the spacecraft in January 2006 aboard an Atlas V rocket, one of the fastest departures from Earth in the history of spaceflight. In fact, New Horizons passed the Moon in just 9 hours. That's about 10 times faster than the Apollo missions. After this record-breaking launch, New Horizons used Jupiter's massive gravity to slingshot itself deeper into space in 2007, shaving years off its journey. But even with this gravity assist, the spacecraft still had an incredibly long road ahead. For much of the journey, New Horizons remained in hibernation mode to conserve energy and minimize wear on its systems. It would awaken periodically for systems checks, but mostly it slept while drifting through the cold, dark void. It wasn't until late 2014 that the spacecraft finally began to wake up for its final approach. As it neared Pluto, mission controllers at NASA's Johns Hopkins University Applied Physics Laboratory started preparing for the most crucial phase of the mission. On July 14, 2015, the world watched as New Horizons made its closest approach to Pluto, just 12,500 kilometers from the surface. It flew past at a speed of nearly 14 kilometers per second, snapping thousands of high-resolution images and collecting data on everything from Pluto's thin atmosphere to its icy terrain. And what we saw was nothing short of revolutionary. Pluto, once thought to be a dull and barren rock, turned out to be a geologically active world with mountains made of water ice, vast nitrogen plains, and possible signs of subsurface oceans. The most iconic image of Pluto featured a large heart-shaped region officially named Tombaugh Regio, in honor of Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The heart-shaped area wasn't just photogenic, it held scientific clues. Half of it, called Sputnik Planitia, was a vast nitrogen ice plain with almost no craters, suggesting that it was geologically young, perhaps even less than 10 million years old. This indicated that Pluto was still undergoing internal processes, despite its distance from the Sun. New Horizons didn't just study Pluto. It also revealed details about its 5 known moons. Charon, the largest, is so massive relative to Pluto that they actually orbit a common center of mass in space, effectively making them a binary system. Charon's surface is marked by deep canyons and dark regions, showing evidence of tectonic activity and possibly ancient cryovolcanoes. This kind of data transformed our understanding of what a dwarf planet could be. Pluto wasn't a lifeless ice ball. It was dynamic, complex, and surprising in almost every way. It forced scientists to reconsider assumptions about planetary classification, geology, and even the potential for life in distant icy worlds. Even more impressively, New Horizons achieved all this during a brief flyby lasting only a few hours. Because it was traveling so fast, it couldn't slow down or enter orbit around Pluto. All of its observations had to be perfectly timed and executed with surgical precision. And they were. After the Pluto encounter, the spacecraft continued its journey into the Kuiper Belt. In 2019, it performed another flyby, this time of a much smaller object called Arrokoth, formerly known as Ultima Thule. Once again, New Horizons sent back invaluable data, further unraveling the mysteries of the early solar system. To this day, New Horizons remains one of NASA's most remarkable deep space missions. It showed us that even the coldest, most distant corners of our solar system can be full of surprises. And perhaps more importantly, it reminded us that exploration never truly ends. It just moves a little farther into the unknown. Stay with us as we dive even deeper into the story of New Horizons, Pluto, and the mysterious frontier of the Kuiper Belt, right here on Infinity Beyond.